Hello, everybody. How are you? I hope you are well. Welcome to my talk, Functional Composition of the Universe. First of all, thank you for being here, and I hope you get fun in the next few minutes. Okay. First of all, a brief introduction about me. My name is Juan López, and I'm working in this software world for the last 15 years, more or less. I have been working in all kind of companies, in startups, in big data companies, or big consultancy companies. Okay, but now I'm working in Backlink. Okay, here we are doing an incredible platform. Okay, with Scala microservices, and my role here is to lead this part through building the tech strategy. And we are receiving more than 20,000 requests per minute, so we are doing an incredible job. Our team is awesome, and our platform is very good right now. And talking about my presentation, the objectives, at least for me, are to have a better understanding of function composition and to understand the power of Scala, scala.js, and beyond that, the power of functional programming. How we are going to achieve that? Okay, first, getting a few astronomy knowledge. That I think is a very cool topic. Probably most of you love it. And coding Scala, that I think is always so fun. Okay. Okay, we're going to use Scala.js. Probably most of you know Scala.js. There were some conference in this ScalaCon edition talking about Scala.js. So I think it's been trending. But if you don't know it, Scala.js is the dialect of Scala that compiles to JavaScript. What does it mean? That you can code in Scala and you will have JavaScript code in order to execute it in your browser. Okay, this is awesome. Okay, okay, you can check their website, but basically they are talking about three main features of Scala.js. The first one is the correctness. Scala is a language strongly typed, and if we are coding in Scala, so we're going to have guarantees of your quality of your code. Okay, no more mixing up strings or numbers. And the second one is the performance. If you are not expert in JavaScript, at least I am not. It's so difficult to do a very efficient JavaScript, and with Scala.js, it's incredible because it optimized your Scala code into highly efficient JavaScript. Okay, the generated JavaScript is both fast and small. This is incredible. And last but not least, interoperability. With Scala.js, you can use many libraries of the JavaScript ecosystem. And for me, it's something mind-blowing to build a React application coding with Scala. So if you don't know it, I encourage you to try it. Okay, the name of this talk is Function Composition of the Universe. So first of all, we need to understand what a function is. Okay, we have two ways to explain functions from two different perspectives. The first one is the math perspective. In maths, we have a perfect definition about what a function is, and it is that a function is a binary relation between two sets that associate each element of the first set to exactly one element of the second set. Okay. Why do I think that it is perfect definition? It is a perfect definition because it is talking about determinism, okay? And the second perspective is the computer science. I think it's something weird because for many years we were talking or we were calling function to something that basically they were not. So now we're using this adjective, the pure, in order to talk about pure functions, real functions, okay? And what a pure function needs. First of all, the function return values are identical for identical arguments. So they are deterministic. This is mandatory for a function, okay? And the second one is the function application has no side effects. Okay? We're talking about no mutation of local static variables, non-local variables, mutable reference arguments, input-output streams, okay, this kind of things, okay? And if the name of the talk is functional composition of the universe, we need to understand what the composition is. But before that, only to say that functional programming is a paradigm where programs are built by applying and computing functions, okay? So, composition. What composition is? Basically, it's a mechanism to combine simple functions to build more complicated ones, okay? This is so important and it's useful because with that, probably we are going to get a better code, a clean code in terms of maintainability and reusability. Talking about more things, not only about coding, probably most of you are using composition because probably you are working on big systems or Scala, platforms with microservices or data pipelines or so on. And they basically may be built by composing whole programs. This is so interesting because you are resolving a big problem, doing small functions, small parts of your problem, okay? This is so good. And, okay, we're going to understand the composition coding with Scala, of course, okay? First of all, I'm going to do a brief walkthrough around the code because obviously I did something before the talk in order to take advantage of the time. Okay, first of all, we have some types and some type classes here with their companion objects. And after, probably we're going to return here, but what do we have? Here we have this class, and here is where part of the scala.js magic happens because with scala.js you can interact directly with the DOM of the browser, and here we are going to use scala.js in order to interact, in order to create a canvas and to put some elements in this canvas and move it and so on. Okay. Okay, and what we are going to do also is to call to a function from our JavaScript every millisecond, okay? This function is, okay, our main function here. So this is our universe right now. This is the browser, okay? And here you can see the nothing. Basically, probably if you have seen or have read the never-ending story, probably you don't want to see the nothing a lot of time. So we're going to fill the universe with something, okay? Okay, we can start with the most important thing in the universe. Probably you know exactly my dog, okay? This is the most important thing of the universe. So, okay, we're going to compile it. And you can see here my little dog, or maybe you cannot see because, okay, it's too small. So how can we fix it thanks to the composition, okay? So we're going to compose the driver function with the make function, okay? We need to put here the type of the class, we compile it. Okay, and you have here my little dog. It is so beautiful, no? Okay, we can write in this way the composition of function, but we can also write it like in maths, I think, because in maths we have something like x, okay? We could write something like this. Works perfectly, but I think in this talk we are going to use the syntax in order to do more explicit the compose of the compose word and the composition of functions. Okay, so perfect. We're going to continue with some theory. Okay, remember the name of the talk is functional composition of the universe, so we need to understand what the universe is, okay? Probably it is the first question that comes to our mind when we talk about the universe, okay? It seems like simple question, but I think it's so difficult to answer. But okay, basically the universe is all of space and time and their content, including the comets, the galaxies, the stars, and so on, okay? But today we are going to talk about planets, stars, galaxies, and satellites, okay? What we can say about these objects, okay? We can talk about the materials, the atmosphere of the planets. We can talk about the energy or the energies between them, the forces between them, how do they live in the universe. But today we're going to put the focus on their movements. This is known as celestial mechanics. Okay, it is so important because it explains the why and how the objects are moving in the universe. Okay, so why do they move? First of all, remember, everything is moving. Every single object in the universe is moving in this moment, okay? And there are many types of movements, but today we're going to explain the two simplest ones. The first one is the rotation. The rotation is when an object is moving around itself, and the translation is when an object is moving around another one, okay? There are two types of translation. The first one is when an object rotates for another one for a long time. Okay, this will be the case of an elliptical orbit. And the second one is when one object has interaction with another one, but escaping the rotation in a moment. Okay, this will be the case of parabolic or hyperbolic orbits. Okay, something amazing for me, something mind blowing, is that we understand these movements from more than 5 centuries ago because Kepler explained it in their Kepler laws, okay? And without astronomy technology and knowledge. Okay, so we're going to explain the how with coding, okay? First of all, we're going to draw the center of our system, okay? What is in the middle of our system? Yes, the sun, because we are not geocentrics. We don't have a stupid mindset, okay? So we're going to draw the sun, okay? And we're going to remember that everything is moving in the universe. So what we can do here is to rotate the sun, because obviously the sun is rotating around itself, okay? So, okay, we're going to fix it. And okay, we have here this one moment. Okay, we're going to put here the bar, but I promise that after we're going to fix these mutable variables. Okay, but I need to change it for a moment. Okay. Okay. So we need to call to rotate. Okay. Okay, if we compile it, do we have? Okay, nothing. Why? Because we're having an error and we can see it in our browser. Okay, implementation is missing. Okay, perfect. So we're going to fix it. We have the rotate in our type class, and we have in the companion object this in order to do a better super syntax here. But what we need to fix is that, okay? Okay, here the only thing we want is to copy our star, okay, and we want to change is the rotation of the image. So we are going to copy our image, okay, and we are going to change the angular rotation. For that, we're going to use the rotation of the star. Every star can have a different rotation, obviously. So angular rotation, that's it, our function, because every star has a different rotation, okay? is here, 2 double, 2 double. So we're going to compile it. Yes, we have our sun in the middle of the universe and rotating around it, okay? What else we have in the universe? Of course, we have the Earth. So we're going to draw our Earth, okay? Planet, compounds with the rotary planet. We're going to rotate it. After we're going to use the implicits instead that, but now we're going to use it. The Earth and here. Perfect. So what we had the problem. Okay, yes, I forget something important. We need to orbit the Earth around the Sun. So we're going to use the orbit function from planet to a star. Call it from planet to the Sun because we want to. Perfect. So we have our Earth rotating around the sun, so we can see here the rotation and the translation. Here we have elliptical orbit, and you can see here is close to the sun and here is farther, okay? So what else? We know the how, and we need to understand why do they move, okay? First of all, this is a matter of balance between two forces, always in the universe. Gravitational force, that basically this force that is the force that makes that an object attracts another one, an inertial force that basically is the force by default. There are some theories about why the object has this inertial force, but the most extended one is the theory that this force comes to the Big Bang explosion. Okay. Okay, so everything in the universe is a perfect balance between these two forces. Okay, this is so important. Okay, so we're going to return to the code. So I have prepared it before a slide in order to understand. Okay, so with that, we're going to understand. Okay, we have the mass of the sun. Okay, we can change it with the slider. Okay, so what do you think is going to happen if I put a lower mass of the sun? Exactly, we have a different orbit. We have a lower acceleration because of the gravity is lower because of the mass of the sun impacts directly on the gravity. Okay, so the velocity also is lower. And what do you think is going to happen if I put a mass very low? So yes, exactly, the Earth is leaving our system and probably you are so cold now. Okay, but returning to the current situation, what do you think is going to happen if I put a higher mass to the sun? Exactly, we have more gravity, so we have more acceleration, so we have more velocity, and we have a different orbit. And what do you think is going to happen if I put a very high mass to the sun? Exactly. We have not more Jira tickets anymore. Good news, but we are all dead, so there are bad news also. Okay, just kidding. Returning to the universe, what else we have in our universe? Yes, of course, we're not alone in the universe, so we have more planets, okay? First of all, I'm going to fix it. I'm going to delete it. Okay, so in our model, we have in every star has a list of planets. So what we can do with the composition? Okay, we can try to compose it with a new function, and this new function could be something like orbit planets. Okay, so we're going to write here, for instance, planets, and basically it receives a star, and we need to pass it the implicit of the rotary class, and it is a planet. Okay, and it it's gonna return the star. Okay, so here we want to copy the star, and here we want to change the position of every planet. Okay, so we have it, the planets, map for every planet. Okay, so we have for every planet. What we can do here is first draw every planet. Okay, so we compose it with locally the rotate function, and we want to orbit every planet around the sun. Okay, so orbit, we want to planet and for every star. Okay, we have it, compiling, and yes, we have two planets here. Okay, Mars and the Earth. Okay, with different orbits, with different velocities, and so on. Okay. Okay, what else? We can add more planets, but I think it is not interesting in the talk. Probably it could be interesting for homework for you, okay? Because I'm going to pass at the end of the talk the code, okay? So what else we have in the universe? Think about if tonight you are taking a look to the sky, probably you can say something like, it's true, it's up there, or something like this, like Mulder, but probably you are gonna say, okay, oh, the beautiful moon, exactly, the satellites, okay? So what we can do is for every planet, okay, because basically every planet has a list of satellites, we can, moment, yes, we want to compose it with the orbit satellites. Okay, so with satellites is the same that before. Okay, with the orbit planets function. So if we compile it, exactly, we have the moon around the Earth and Deimos and Phobos around the Mars, because Mars has two satellites. Okay. Okay, perfect. So you can see like that component functions, we can build something bigger in a moment. Okay. So, okay, let's continue. Okay, here we have, okay. Okay, here you have a quote from Carl Sagan, but what I want to explain here is that everything is moving in the universe, remember? So the stars are moving around another thing also, okay? We have the galaxies, and in the middle of the galaxies we have a black hole, and around the black hole are orbiting a lot of stars. Okay, one of these stars is the sun. Okay, and what else? Okay, as you can read here, we don't have only one galaxy in the universe. We have we don't know exactly how many galaxies we have, but too many probably. Okay, so okay, coding time again. What we can do here is to first of all fix that. Okay, and we're going to change it after later. Probably we're going to fix it. Okay, the evil variables. So what we can do here is to get the black hole, draw it, and orbit stars. Okay, okay, sorry. Write the type, and if we compile it, okay, we have the sun. Okay, if we want to draw the sun, we have it, but if we want to draw the planet, the orbits, and so on, it's all about composition. So what we need to do is for every star, we need to compose with the orbit Okay, so we have it, our little galaxy. Obviously, the scale is wrong because it is only an example. So taking in account this, okay? And okay, we have a lot of galaxies. So what we can do if we want to put more galaxies? Exactly, we can compose and compose and compose again in order to have more galaxies. So what we can do here is to basically orbit galaxies, and we can pass a list of galaxies, okay? And thanks for the composition, we have two galaxies, okay? Yes, there are the same planets, the same image, but it's only an example, okay? So, perfect. We're going to return to the previous state, okay? Okay, and we're going to continue understanding more things. Okay, at the beginning of the talk, we were talking about my little dog alone in the universe, but if we want to draw my puppet in the universe, we need to understand how can we calculate the position of my puppet. Okay, first of all, it depends of its movements, but it depends also of the Earth movements because my puppy lives in the Earth, and it depends of the sun movements, and the sun movements depend on the galaxy movements, and so on. Okay, so basically the position of my puppy is a composition of all these movement functions. Okay, so sorry, what we can do here is to we go to the stars. We want to planets. What we can do here is to compose it with a function. Okay, and okay, that's it. Oh, I cannot see my dog. Oh yes, of course. I need to change this compose with an n. Okay, this is also composition, but we need to execute the tenants function in the last place because of the layers of the canvas. Okay, we need to draw our puppy. I need to compile it. The last layer. Okay, so you can see there my little dog. Obviously, it is so nervous, and it is playing around the earth. Okay, okay, that's it. Thank you so much. I'm going to share with you the slides and the repo in order to share this code. You can try to add new planets. You can try to add new objects. I think it is so easy because you only need to add some planets to the list, for instance, and compounding these all movements, you can have all these objects moving around the universe. Okay, and if you have some questions, now you can do it, and if not, you can do it through Twitter, for instance. Here you have my account, and that's it. Thank you so much, and I hope you got fun for these minutes.